The goal of this video is to learn how to compute the volume of cones and pyramids. We already learned how to calculate the volume of prisms and cylinders, so we're going to relate all the volume of cones and pyramids to that. To calculate the volume of a cone, it's very similar to a cylinder because they both have that circular base. Okay, pyramid is similar to some sort of prism. So if it's a square pyramid, it's similar to a cube. If it's a hexagonal pyramid, it's similar to a hexagonal prism. Now the only difference is the volume of a cone or a pyramid will be a third of the size of a cylinder or prism. Okay, so to calculate the volume of either of these things, you learn the formula as area of the base times the height of the whole 3D shape. Now to calculate the volume of a cone or pyramid, you're going to take that formula and divide it by 3, because the volume of a cone or pyramid is a third of the size. So it'll be 3 times smaller than a cylinder or prism. Okay, so this is the essential formula you need to know to calculate the volume of a cone or a pyramid. So for a cylinder or a prism, you take area of a base times height. For a cone or of a pyramid, you'd take whatever that area was and you divide it by 3. Okay, that is the essential formula. Study it, know it, love it. You need to know that to calculate cone or pyramid, the volume. So I'll give you an example. If you want to calculate the volume of a cone, you would take the area of the base, which of a cone, it's going to be a circle. So to find the area of the base, it would be pi r squared. Then you'll multiply it by the height of the cone, so how tall that cone is from the apex to the ground. We'll call that h. And then you would divide it by 3, because this is how you'd calculate a cylinder. To get a cone, it's a third of the size, so we divide by 3. So this is just an example. Okay, remember a note about height. This is really important, so I'm going to keep repeating it. If you're calculating surface area, you need the slant height because it's on the surface. Surface area, you need the height on the surface. To calculate volume, you need the normal height. Okay, so the height that's perpendicular to the base. Perpendicular to base. So it's like if you're measuring the height of a mountain, you'd go from the tippy point top, stick a pole in it, and it'd be perpendicular to the base. But if you want to measure the slant height of a mountain, you would measure like how far it is down the slope, which would be like at an angle. So this is the height that's on the surface. This you will fill out after we do the demonstration. You'll know what I'm talking about. Okay, an example, you have a pyramid with a rectangular base that is 10 by 12. So one side of the base is 10, one side is 12. Okay, the pyramid is 1 meter tall, which is just the regular height. Okay, when I say the regular height, that's the height that's perpendicular to the base. So there's my perpendicular line. It starts at the apex, goes straight down. Now the only confusing thing here is your base is 10 centimeters by 12 centimeters, but your height is measured in meters. So we want to get a common unit. So 1 meter is equal to 100 centimeters. So now we have consistent units. I'm going centimeters, centimeters, centimeters. So I had to do a little conversion there. So I'll call the height 100 centimeters. And this was 10 centimeters and 12 centimeters. I want you to find the volume. In order to do this, you're going to take the area of the base times the height and then divide it by 3. The base is a rectangle, so to find, and actually I'm going to rewrite the formula because the more times we write it, the more times you remember. So the area of the base, and then I'm going to divide it by 3. Okay, the area of base is just a rectangle, so you do base times height. Okay, now base times height in this case is 10 times 12. Okay, or you can call it length times width, because I know it gets confusing with 2 heights. Now you're going to multiply the area of the base times the height, which the height is 100 centimeters. And then you're going to divide it by 3. So that gives you the area of the base is 120. Multiply it by the height of the shape, which is 100 centimeters, or 1 meter. And then you'll divide it by 3. So 120 times 100 gives you 12,000 centimeters. Okay, divide that by 3. And the total volume of this pyramid is 4,000 centimeters. And since we're talking volume, it's centimeters cubed. So area would be centimeters squared, volume centimeters cubed. Okay, so the trick to this one was just you had a conversion. So if it's 1 meter, but we're talking centimeters, like put that into all the same unit. Okay, this one, a cone has a slant height of 20 centimeters. The base is 24 centimeters across. When I say across, I mean from one end to the other is 24 centimeters, which you can call this the diameter. And it wants you to find the volume. In order to do that, you need to know the area of the base times the height. Now remember, this is the formula for a cylinder. Area of the base times height. To get a cone, it's a third of the size, so you divide by 3. Okay, the area of a base is a circle, so to find the area of the base, that's just pi r squared. So it'd be pi times your radius squared. Now my diameter is 24. The radius is just from the middle out to an edge. So if the whole thing's 24, this piece here would be half. That would be 12. So instead of saying pi r squared, I would say the area of the base is pi times 12 squared. That's my radius. Okay, now the height is the distance from the top, which is called the apex, that comes perpendicular to the bottom at a right angle. And this I do not know. Okay, I know the slant height, but the slant height's on the surface, so that calculates surface area. So if you don't know the height, then you have to go and find it. If you already know the height, you don't have to. This case, you don't. So you see that this creates a right triangle here. So let's just redraw that. Okay, my slant height is, my hypotenuse is 20. My base of this right triangle is 12, because that's the radius, and I don't know how tall the shape is. Okay, so I have to do Pythagorean Theorem then to find the length of my height, which is my missing side of my right triangle. Okay, so the hypotenuse always has to be the c squared. These are interchangeable. So in this case, I'll do x squared plus 12 squared equals my hypotenuse squared. Okay, simplify this up. 20 squared gives you 400. 12 squared gives you 144. Subtract 144 from both sides, so that'll cancel here. 400 minus 144 will give you 256. In order to undo a square, you'll take the square root of both sides. So the square root of 256 will give you, drum roll please, 16. So x is 16, which remember our 16, the point of that was to figure out how tall the cone is. So the cone is 16 centimeters long. Okay, so I can plug that in for my height now. So I did all that just to find the regular height. And then I'll divide it by 3. So simplify that up. 12 squared is 144. So the area of the base is 144 pi. Multiply by the height, 16, and then divide by 3. So in my calculator, I'll plug in 144 times pi using my pi key. That's going to give me about 452.39. Okay, so this is about 452.39. Then I'll multiply that by 16, which is about 7,238. Okay, but then I'll divide that by 3. And when I divide that by 3, I will get approximately, because I've rounded here, 2,412.74. And we're talking centimeters, and it's volume, so it's centimeters cubed. So write your units on there. Okay, so I basically just multiplied this out, divided by 3, and I got my final answer. Now this is how you find the volume of a cone or a pyramid. So it's like finding a cylinder or prism, except because it gets smaller towards the top, it's going to be a third of the size. Okay, so after the demonstration, you want to explain why this formula makes sense. And then I have some problems for you to try on your own, including, just a regular find the volume problem and some of those backwards problems that we've been working on. Okay, so try those on your own until everyone is finished, and I hope you learned lots about volume today. Thank you.